Welcome to another video from explainingcomputers.com. This time it's very exciting indeed, as I'm going to build my first desktop PC with an ARM processor. Specifically, we're going to be using this ROC5 ITX along with a Mini-ITX case and an SSD. So let's go and get started. Right, here we have our ROC5 ITX, which, whilst it looks like a Mini-ITX motherboard, is technically a single board computer because it's got a pre-soldered processor and RAM. Talking of which, this is available with either 4, 8, 16 or 32 GB of RAM, and this particular board is 8 GB and it's priced at $119.90 on AllNet, although I purchased from A-Race for £96. As we can see, the box is actually inviting us to build our own ARM PC, so let's open it up. Very simple unboxing. We just lift the piece of foam and wow, let's get it out. This feels like new territory, doesn't it? ARM and Mini-ITX form factor. Let's get it out, and we've got a I/O shield. I guess we'd have to for fitting the board in the case, and this is that's probably M.2 screws, I think, but let's get rid of that. Get the board out of its bag. Is it sealed? Only slightly, and hopefully we can get it out. And come on. Oh, look at that. This is a very exciting new board. So let's turn straight away to the specifications, and what we have here is a standard 170mm or 6.7-inch square Mini-ITX board that can be fitted into any Mini-ITX or larger desktop PC case. It's based on an octa-core Rockchip RK3588 system on a chip with 4 ARM Cortex-A76 cores running at up to 2.4 GHz and 4 ARM Cortex-A55 cores running at up to 1.8 GHz. And it also contains an ARM Mali G610MC4 GPU and a 6-TOPS NPU. Near to the SoC we have our RAM, which is 8 GB as I mentioned earlier. It's DDR5 and it's quite difficult to see here being black on black. And then just above the SoC we have 8 GB of eMMC flash storage, which is used for an onboard operating system called ROOBI OS, which is used to install other OS and which we'll investigate later. And over here we have a holder for a CR1220 real-time clock battery. If we take a look at the back panel, we find a mass of things to drool over, starting with 3.5mm and SPDIF audio connectors. Next we have 4 Type A USB 3 ports, and beneath these 2 full-size HDMI connectors, one of which supports up to 8K 60 frames a second output, and the other up to 4K 60 frames a second output. There are then 2 2.5 gigabit Ethernet ports, which support power over Ethernet, and beneath these 2 Type A USB 2 ports. Next, there's a full-size HDMI input connector that can receive up to 4K at 60 frames a second, and then a Type C USB port, and this is USB 3 and supports OTG and can provide up to a 4K 60 frames a second display output. And then finally we have a 12-volt barrel connector that provides one way to power the board. However, on the next edge there's a standard 24-pin ATX power connector, which I find really cool to have on a board with an ARM processor. And we also have 2 power over Ethernet headers. Spinning 90 again, there are 4 standard SATA connectors, which I presume are SATA 3, although I can't confirm this in any specifications. And they've also each got next to them a power header, although of course we don't necessarily have to use these headers because this board can be powered with a standard ATX power supply, so we can use the power connectors from the power supply to power SATA drives. And so this opens up all kinds of possibilities. This is an ARM board that you could easily use to connect to 4 3.5-inch hard drives powered from a standard ATX power supply. That's really cool. Finally, on the last edge, there's even more connectivity, starting at the left end with embedded DisplayPort, touch panel and MIPI DSI connectors for connecting an LCD panel, and we also have here two MIPI CSI connectors for hooking up cameras. In addition, we have a microSD card slot, recovery and debug headers, and a 2-lane PCIe 3.0 M.2 slot. And this is M-keyed to take an NVMe SSD and will be fitting our system drive in this slot. Moving along, there's then another M.2 slot. This one is E-keyed to take a wireless module, and we also have a front USB connector. This allows us to add 2 extra USB 2 ports, and next to that we have a front audio connector and front panel connectors, which again I find it's very exciting to have on ARM hardware. And so there we are, an ARM board with more connectivity than I've seen on any x86 Mini-ITX competitor. And in fact, we haven't even looked underneath, we should do that as well. There we are, not a lot to see underneath, but there is one more MIPI DSI connector for connecting an LCD panel. And the final thing to note is that whilst this board does have mounts for a cooler, as we can see, it's also got a 4-pin fan header that no cooling solution is provided. And given the holes we have here, lots of different coolers could probably be used, and there is also an argument to say we might not need a cooler on an RK3588. But I would like to use a cooler, and I've managed to purchase one of these, which is the dedicated Radxa unit for the board. So let's open it up. If you're wondering, this costs me £4, or it sells for $5, so they don't overcharge for the cooler. And inside, this is a serious cooler, isn't it? Whoa, it is, yes, wow. This is a serious cooler for an ARM board. And it's great to say we get a spare thermal pad, and I do suspect that given the size of this heatsink, that the fan may not actually be required. Now, in addition to the ROC5 ITX, we're going to need a few other components, which is what we've got here. This is clearly the case. And we've also got a CR1220 battery. We've got a SATA SSD. This is one of my test 2.5-inch SATA SSDs. And I want to fit this so we can check the speed of the SATA interface on the board. And then finally, we've got this, which is a crucial P3 PCIe 3.0 NVMe M.2 SSD. This is going to be our boot drive. Let's just open this up. Thanks there for some help from Stanley the Knife. And yes, that's our M.2 SSD. But the exciting thing here, let's just move these aside, is of course the case. And this is an in-win shopping Mini-ITX case. So let's open it up. Quite heavy. I think we do that and that and that. Looking forward to seeing this. And need it coming out. It is. That can go down on the floor. And this is a nice case, I think. This is very exciting. And let's get it out of the bag as well. Where's the bag open? There it is. And as I've said, this is quite a heavy case because the metal it's made from around the edge, this is 4mm aluminium or aluminum, depending on where you are in the world. And when choosing this case, my selection criteria were for something that was as small as possible that could take a Mini-ITX board, along with at least one 2.5-inch drive, and which included its own power supply. And here, if we just remove this top panel, like that, we can see inside as well as the things they give us. Here's some exciting bits of plastic for the front, various wires, power cable, etc. But we can see there is a built-in power supply. This is down there. This is a 150 watt power supply. It's supposed to be very quiet. And we can also mount two 2.5-inch drives, which we do on the other side of the case. Let's take a look at that. There we go. And yes, we can mount two 2.5-inch drives in here. And if you're wondering, this case cost me £106.80, and it also sells for about $129. So it's not a cheap case, but it is a very, very nice Mini-ITX case. I can tell already I really like this case. And my plan with this is to use it for testing a number of interesting Mini-ITX boards, of which the ROC5 ITX will be just the first. Right, it's now time to put things together, and I've already fitted the real-time clock battery, which just clicked in, and then I moved on to the cooler, which first involved putting the heat pad on top of the SoC, and then putting the backing plate under the motherboard and screwing in the cooler from the top. And then after that, I plugged in the fan. Next, we need to fit our M.2 system drive, which just goes in here like this, and it just needs a screw. There we go. We now have 0.5 TB of storage, and it's now very much time to think about fitting this in the case. And over here we have the case, but before we can put the motherboard inside, we need to fit this, which is the I/O shield. So let's bring in Mr. Scissors and get into this. There we are, get it out. Rustle, rustle, and this now has to fit in the back. As you'll know if you've watched builds on this channel before, I hate fitting these things. They can be an absolute swine to get in, or they can go in really easily. That one went in really easily. And so now, in theory, we can put the motherboard in the case. And I say in theory because I tried to put it in a few minutes ago to test before I'd fitted the I/O shield, and it didn't fit. And the reason it didn't fit was because the backing plate that holds on the cooler was too tall. And I've got the backing plate here, I've now taken it off, and you can probably see it has little pins which stand proud of the surface, and those normally would actually go through the holes in the motherboard. They don't on the ROC 5X, so you have a rather thick backing plate, and it means when the motherboard sits in here and it sits on the mounts and the corners, it's taller than it should be, and therefore it just doesn't fit. And so what I've done to fix the problem is to raid my collection of nuts and bolts and things like that, and now on the back of the motherboard we've got all washers and nuts holding the cooler in place. And so in theory this will now fit. It's an interesting fit given all the wires here. The main problematic wires here are the ones for the front USB 3 ports on this case, which ironically I can't connect because I don't have any on this motherboard, but this is a difficult... There we are. Is that fitting? Oh, that's gone in okay. So let's now fit the screws. There we go. And contrary to what I expected a few minutes ago, I've managed to put together an ARM PC. So we just need to deal with the rest of the wiring, the first bit of which is to fit the main ATX power connector, which needs to go in here. And it's always difficult to give you a decent shot of this, particularly black on black, but there we are. It is now fitted. So we'll now move on to the front audio connectors, which will fit by the magic of filmmaking like this, and the front panel headers, which will go in like this. And with copious amounts of magic sprinkled on to get my wiring as neat as it can be in a Mini-ITX case, my problem as anticipated was these front USB 3 leads. There's nowhere to put them. They've got to stay there. But everything is relatively neat, certainly functional, and it's included fitting a SATA lead which goes through to the other side of the case so we can connect up this 2.5-inch SATA SSD. But we're not going to do this right now for reasons which will become clear, because now it is time to get this thing connected up, to make use of all these lovely connectors, and to see if we can install an operating system. Right, I've now got everything connected up, and in theory, when we turn on the power, this will boot from ROOBI OS on its eMMC flash storage and allow us to install an operating system on its NVMe drive. So that's the theory. Let's try it in practice. Let's turn on the power. Oh, the fan has come to life. The fan is currently at full pelt. It's quite noisy. Maybe it'll slow down. Nothing on the screen yet. Oh, it's very worrying. Oh yes, we've got something. That's okay. Looks like things are booting. Oh, and the fan has slowed down. And we've arrived in what I think is ROOBI OS. And in theory, I can go Control, Shift and Plus to make things a little bigger for us on the screen. That's nice. And I'll click on Start. And we've got to accept software license agreement. There it all is. What do I do now? Tab. Oh, there's a little thing now. I can click in there and next. Network testing. My network is okay. We're on an Ethernet network here. Everything is obviously working fine. And we now can select an operating system. We've got Debian with a KDE desktop or Armbian. I'll stick with Debian and next. That's obviously okay. And yes, I'm happy all the media will be emptied, as it says here. We will confirm. And there we are, it's downloading our operating system. And we've now moved on to the Debian KDE installation. And there we are, success! Everything has been installed. Less than 10 minutes since I first booted up the computer. It's working and it's clearly going to reboot itself. So this is another moment of truth. Fan is getting noisy again. Let's now see what happens. We'll speed forward in time. And here we are. We have arrived on the desktop. What is the password? I don't know, is it? Is it Radxa? Looks like it is Radxa. That was a good guess, wasn't it? Fan's nice and quiet again. And this is very impressive, isn't it? This was a very painless installation. Plug the computer into a network, it sets up its own operating system. And here we are, we've arrived on the desktop. So what I'm now going to do is to have a look around myself, make a few scaling changes so things read better on video, and I'll come back to you after that. Guess what? I've now got our ARM PC entirely complete, and that included, before fitting the panels, putting in the SATA SSD so we can test the speed of the SATA interface. So let's go across to the desktop. Here we are. All I've changed here since I saw you last is scaling. I've not changed anything in terms of installed applications, and I've found performance here is very good and very stable. If I take this window and just move it around, you can see clearly this is a GPU accelerated desktop. It works very well indeed. If we go down to the menu, there's not that much pre-installed. There is a little editor there for coding. Under graphics, we basically have viewers. Internet there, we've got Chromium and Firefox, which is good to see. Multimedia is basically, again, players. We don't have LibreOffice. I'm sure it could easily be installed. And then we've got various settings, and we have under system the usual types of things, including Info Center, which doesn't give us that much information actually. It tells us what we're running here in terms of software, but if I look under devices and we go to processors, we can see our 8 cores. We can't see anything about the processor, including we can't see its temperature, which is a bit of a shame. Anyway, let's run up a web browser, show you web browsing performance. It is very good. Chromium runs very well on this system. And I bookmarked a few things, not least I bookmarked the GPU internals for Chromium. And this does show us we do have hardware acceleration for video decoding, which is good to see. So let's take a look at YouTube playback. You knew I'd do it, got to do that in the video. There we are, playing away at 1080p, and no problems at all. Well, we've had one drop frame, probably just things have started out, but even if I move the mouse around, doesn't care. This has got very, very good YouTube playback. There's no doubt at all I'm going to be using this as a media PC on occasions, and it'll work very well indeed. Anyway, let's just get rid of that because I said we'd test out drive speed. So let's go back to applications and system and bring up the console. There it is. And if we do an ls-blk, we can see what storage we have on the system, which includes our NVMe boot drive, as well as the SATA drive we added, and also a bit of eMMC flash storage. So let's just clear that to be tidy and test the speed of the NVMe SSD, like that. I have to put my password in. What are we going to get? And it's 948.47 megabytes a second. Remember here the M.2 interface is PCIe 3.0 2-lane. And we'll also test the speed of the SATA drive, like that. This gives us a surrogate for the speed of the SATA interface. What we're going to get on this, 405 megabytes a second. So it clearly is a SATA 3 interface. It's giving us more than the 300 for SATA 2. But this drive, I think, can do about 520, 530. So we're not getting full SATA speed, but it's still not too bad. And I'm sure you're wondering about power use. So let's bring up a power meter. You can see we're idling along here at about 11 watts. And the only way I've found to get a temperature reading is to use this command. which I think is reporting our temperature here as 40.69 degrees, which is not too bad. The system's been running a little while, and I'm sure you'd like to see what happens when we stress things out, particularly in terms of power use. So I've got a sysbench command in the buffer somewhere. There we are, and yes, we can see our power use going up to about 15 watts, which is not bad for an upload figure, is it? The idle figure down at about 10-11 watts is a bit worrying, really. It's a bit high for an RK3588 system. Maybe the ATX power supply here isn't incredibly efficient, and we do, of course, have 2 SSDs fitted. But anyway, we're back to our idle power use there, which is about 11 watts. And we will take a final temperature reading. Not sure it'll change much in that period of time. No, still 41.615 degrees. So there we are. I'm impressed with this system. I like running Debian with a KDE desktop on the ROC 5 ITX. So there we are. I've built an ARM PC, and as you probably gathered, I'm rather excited about it. And some of you probably are wondering why, but for me, having been able to do a traditional build and yet ending up with a system with an ARM processor, that for me at least just shifts the dial a bit. And there are of course many other tests I could do with this hardware, and in fact I'm thinking of making a video comparing the performance of this system, Mini-ITX RK3588, with the N100 Mini-ITX system I built about 6 months ago. And I'm thinking of doing that using Ubuntu as the operating system, because I understand there's a rather good third-party Ubuntu image available for this board. So if you'd like to see me running Ubuntu and comparing performance on a RK3588 versus N100, let me know down in the comments section and I'll make the video. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.